just thought it'd be important to try to record a small video to help you understand orbital diagrams, because today in class on Wednesday, October, I believe it's 26 today, that we did not get fully through orbital diagrams, and I thought it'd be helpful for you with your homework tonight and for tomorrow night. But orbital diagrams is just going to be one more thing that we're going to learn. They're going to be what we fill in, and this is the homework number 8, the back side of number 8, and we're going to fill in the orbital diagrams, which is the outermost row, the final row. You're going to see some written out in number 10 that you're going to fill in arrows. You're going to fill in arrows in number 10, and that's going to be, this is an orbital diagram, and we're going to fill it in for carbon, sodium, germanium, and vanadium. And we're going to fill in these arrows. You also will do it on number 9, right here on the orbital diagram. And on the other side, you want to do the right orbital diagrams. And that's actually going to be for the entire, it says to go, after we go over them, to draw it for the outermost energy level. So I'm going to focus on that, so hopefully you'll be able to draw in the boxes after seeing this. Okay? Here are some. Further in 21, you actually see them filled out. You see how they have boxes for S, for 2S, for 2P, for each individual P, and the 3S. And when they're up and down, these are 2 electrons in each orbital. But when you get to the P sublevel, you actually have some filled up and some only singles. So when we go through this, you'll be able to understand what element would they be filled in here, what configuration will you complete here based on what you see with the arrows. Each arrow represents an electron. So when you have a 1s1, you probably could tell me what this is. It's just the very first element on the chart. If you have 1s1, or excuse me, an up and down arrow, you're going to put 1s2. And then you have 2 electrons, you're going to put the third one going up. I'm sure you can tell me what element is this. The first 2 go up and down, the second one goes up. And again, I'll explain more as we go through this video. But it's definitely going to help you on this final assignment here when you work on number 21, either now or later on next week. Okay, so let's look at what I have written down. I have orbital diagrams are a symbolic way to show how electrons fill in their orbitals. Okay, so we have the levels, the sublevels, S, P, D, and F. Remember that there's 1 orbital for S, 3 for D, 5 for D, excuse me, that's 3 for P, 5 for D, and 7 for F. And so you're going to show them as a series of boxes. So if we do S, you're going to have a box, 1 box. If you have P, we're going to show 3 boxes. We won't use F's too often, but it will be referenced a few times in class. Okay? And how you're going to do that is, let's focus just on the S. Okay? When you do S, you're going to show either S1, and you're going to put the arrow going up, and that represents 1 electron. And what's going on with the electrons is that there's 2 of them in the orbital, and it's really close. If there's only 1, you have 1, but if there's 2, they're really close in the same space. So we show the arrow going up and down as them spinning clockwise, and then this one's showing that it's spinning counterclockwise. And what's going on is that since there's 2 electrons in an orbital, they're really close together, and so it really compensates for being negatively charged in the same space. So we're going to show an arrow going up when you're a single electron in an orbital, and then going up and down when you're filled up. Okay? So you either could be S1 or S2. That could be from the periodic table. It could be this 2s1, it could be this 2s1, this 5s1. This S2 could be the 2s2 from beryllium, or this 5s2 for strontium. These boxes can be for any level, whether it's 1 or whether it's 7. Okay? So if we go on to P and we do P1, you're going to fill the electron up. If you're P2, you're going to have 2 electrons both going up. They want to be in separate orbitals. Okay? And we'll list that out later as being Hund's rule. Okay? But we have P1 and we have P2. We're going to put P3 in a separate orbital. Each of them go in a separate orbital because they want to be in separate spaces. Because they're all negatively charged, the electrons don't want to pair up unless they have to. So that would be like boron in the 2p1 box. That would be like boron. That would be like boron in the 2p1 box. And then this would be like carbon in the 2p2 box. And this would be like nitrogen in the 2p3 box. Okay, and as you keep going, once you get to P4, you're going to put the arrow going down, and then P5 you're going to put this arrow going down, and then P6 you're going to put this arrow going down. So you're going to do the up, up, up first, and then the second half you're going to do P4, P5, P6 all going down. And it's very similar with the D orbitals, the D sublevel. And let me show that too. Okay, when you do a D1, that would be like D1, like scandium, for instance. You're going to do the arrow going up. When you're D2, like titanium, you're going to have the D1 here and the second one here. D3, you're going to fill it in a separate orbital. D4, you're going to fill it in the next orbital. D5, you're going to have its next orbital. And so these are the 5 orbitals, each filling up individually, and then you go ahead and go down on D6, and then D7, you go down, and then D8, you go down, and D9, you go down, and then D10, you'll go down. And so that's how we fill them up on D of any level. It could be the D's in this row, D1 to D10. It could be 5D, D1 to D10. It could be any one of these. They're going to fill in these orbital boxes very similarly. Okay? So what these are based on, when we go through the rules here, I just wanted to give you what the rules are, and you can be able to write these down either tonight or tomorrow in class. But basically, whenever we're filling up the orbitals from low to high, we're going to have, let me go ahead and zero in on this a little bit. I think you're going to get it here. But you're going to have the Opal principle states that each electron fills in the lowest energy orbital available. So you're going to fill from low, 1s, 2s, 2p, then 3s, 3p. You're going to fill from the low to the high, increasing in energy from low to high, including when 3d goes after 4s. Okay? When you do the Hund's rule, it's named after a German physicist, and he stated that single electrons need to be spinning in separate orbitals before they are forced to be in the same orbital. Just remember that these electrons are all negatively charged and rather be in separate orbitals first before pairing up. Okay, that's this going up, 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 and then going down, 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 down. That's the Hund's rule. Okay? Another European scientist from Austria, Wolfgang Pauli, he proposed this rule, stating that a maximum of 2 electrons can occupy a single orbital. And that it's a maximum of 2 electrons can occupy a single orbital, and they can only have opposite spins. Spinning helps to overcome that they are both negatively charged in this small space. Okay, so when you have them going up and going down, you can't have 3 electrons, you can't have 4, you You can only go up and going down. That's what's called the Pauli exclusion principle. Okay, so give a minute here to write these down. You can pause the video to write these down, but that's mainly what the 3 rules are. Okay, so to give you some examples to help you with number 10, okay, the ones you could do these or do the ones that were assigned, but we can also look at how you do helium on one of these charts, okay? But when you do helium, it's just 1s2. So you're going to go an arrow going up and an arrow going down, and sometimes I write the arrows with like a half arrow. I'll try to make them all filled up, you know, with both parts, but I might accidentally just do a half arrow. But you're just going to go up and 1 down because it's helium 1s2. It's in this box here, so you're just going to fill it up on one in the first box going up and down. When you do nitrogen, you're going to have the 1s2, the 2s2, and the 2p6, or excuse me, 2p3. So you're going to go 1s1, 1s2, 2s1, 2s2, and then you're going to go p1, 2p1, 2p2, 2p3. So your configuration is 1s2, 2s2, 2p3. And there's going to be 1, 2, 3 in separate orbitals. Okay, for copper, that's way down at number 29. Okay, and you're going to be going all the way to here. So you're going to have 1s2, 2s2, 2p6, 3s2, 3p6, right all the way down to here to argon. Then you're going to go to 4s2, you're going to go to 3d, and you're going to count the boxes over, and it's going to be 3d9. So you're just going to do the arrows like we done here. You're going to go up and 1 down for 1s2, go up and down for 2s2. You're going to go up, 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 then down, down, down for 2p6, then up, down for 3s2. The same for 3p6, up, down, all 6. Then you're going to have 4s1, 4s2, and then you're going to go over to the 3ds and go D1, D2, D3, D4, D5, D6, 7, 8, and 9. That's what copper would be. And if we do one final one at 42, we got quite a lot. That's molybdenum, molybdenum. It's one of the ones you have to know for next week. And we're going to go, and we can do a shortcut with this. It's at the very end of the 3rd row. That's going to be, I believe that's krypton. And then you're going to start in 5s because you're in the 5th row. And then your D's are going to be 4D, and I believe it goes 4 over 4D4, and you're going to fill that in. So you're going to fill all the arrows in, all the way up, 1 down. It gets kind of lazy, and you just do 1/2 arrow to save time. Okay, go up and down, 1 up and 1 down. You're going to do all the ones in 3D all the way. Okay, and then you're going to do 4P. And this is krypton. This is krypton's configuration. Then you're going to go on to 5s2, 5s1, 5s2, and then 4 individual electrons going up like this. Okay? 4 individual electrons filling up like that. That would be how you do molybdenum. You could actually complete this for number 10 on the back, the 4 other ones you want to choose if you so be it. For the homework tonight, you want to start working on like number 8 and completing all these questions, and then finishing up the back on this number 8 with all these here. There is a typo right here. It's supposed to be 4D10. Okay, and when you look this up, whatever ends at 5P2, you can use your chart to find 5P2. It would be this is 5P1, this is 5P2. So down here, this would be 10. It would be 10 as your element. So you can fill in 10 right here, and then fill in the orbitals. You can put 1 box for the S2. You're going to put 5 boxes for the D10, and then you're going to do 3 more boxes, and it's kind of hard to put them all in, but I know if you put 1 here, 5 together here, and 3 together here, I'll know it's S, D, and P. But you're going to go 1 up and 1 down for the D10. You're going to go up, down. Just go ahead and fill them all in because they're full. And then for P2, you're going to go 1 up and 1 up. Okay? And then now you're going to do the valence dots, and that's going to be the final S and the final P. So that's going to be 4 dots around the 10, because you have 2S and 2P. Okay? But please get back with me on Remind if you need any help. You are, on number 9, going to do the complete long form, but you're going to only do the outermost energy level orbital diagram. Okay? And then on the back side of 9, you're going to be doing outermost and Lewis dots, and you only really have to do number 6. If you want to stop at number 6, that's fine. You can do more for next week, but for number 9, you're only doing the first 6, and on this side, you're only doing the first 6. Okay? So I hope this little video helps. I know it's about 15 minutes long, but we'll talk to you later.